I have their cycle time performance of their teams. Okay, and this is the average performance that I have. So manager one average cycle time is 25. Manager two average cycle time is 24, and manager three cycle time is 21, 23. Looking at this example, okay, looking at this example, it seems like that these three managers have no significant difference between their performance. They are kind of at the same level, okay, wherein so this is probably in minutes. Let's take an example. So which means 1 minute is okay. Okay, it is not such a big difference in the performance. He's taking this. His team is manager one's team is taking 25 minutes. Manager two team is taking 24 minutes, and manager three team is taking 23 minutes. Okay, so there is nothing major of significant difference that we have here. Okay, so now, but if I consider the variance here, and we all know the the definition of variance that we covered, how far my value is from the mean. That's how we calculate the variance, which we did in the basic stats. My variance of manager one is, let's say the calculation is 25. Here the variance is only 5. Here the variance is 10. What does that say? What does it say? It says the manager 2, it says the manager 2 has a very less variance, which means their data points are not very far from each other, which means they have a very low spread, which means that they don't have too much variations in the data. It means that they don't have a lot of extreme values here. But here, looking at the average, it sees that while performing average, they are doing well. But in case of manager 1 and manager 3, there are a lot of extreme values. Due to that, there is a huge variance. But in case of manager 2, their average is also good and their variance is also good. So that's what I was referring to. So therefore, when you do a modes median and when you do a test of equal variance, the interpretations are different, because when you do modes median, it tells whether if there any significant difference between their average, their medians. And when you do test of equal variance, they're talking about the significant variance between these 3 or 2 subgroups. Is it clear?
Yeah.
Is it clear to all of you? Okay. So that is test of equal variance, which we usually cover to check the variance. And now there should be a question that why am I checking the variance? What do I get out of it? I am doing a project on improving the handling time or improving the breakage. Okay. Why do I need to check the variance? Because currently looking at the problem, I see that average. So for example, you have scored marks. Okay. So if I consider your marks, so for example, in subject 1, you have scored 100 out of 100. Subject 2, you have scored 50. Subject 3, you have scored 95. Subject 4, you have scored 80. And so these are the 1, 2, 3. And subject 5, you scored 95. If I take the average, it comes out to 84, which means their average is 84. Still there is a guy who has, still there is a subject wherein I've scored 50, but since I've scored good marks in subject number 5, subject number 3, and subject number 1, I've got a compensation. It always happens during our school time and college times, because we always look at the average. But subject 2 is still a problem for me, right? I might face a problem in my higher studies also, because if I don't. Now, if I calculate the standard deviation here, it's 20.4. It's way, very high. Okay. So that's the reason I have concluded that my average is good. But what if there are variants? I need to work on that as well, right? I said it during the measure of basic stats class that why variance is not good for the process, because it will not help me to predict. It will not help me to do the forecasting. And that's the reason test of equal variance is required to be done. Does anybody have any question? Are we clear? Why are we doing test of equal variance and why are we doing the other test like one-way ANOVA or Mann-Whitney?
So when we understand that which one is like for the variance, whether which one is doing good or bad, basis that we go ahead and look into that issue or problem and see how we can improve that. Is that the underlying idea behind doing this?
Yes, so this is basically to check if there's any variance. Okay, if there's any variance, because the higher the variance is, which means there are some special causes, special extreme values in the data. If yes, we have to check both. We have to check both. We have to check both.
So for example, in the manager case or in the subject case, like the one which had 50 as the number might have a high variance, or the manager one which had the high variance of 25. So we need to go and check what are the causes, that is because of which, even though the average is good, but we have such a huge variance for this particular team. So we have to go and understand the causes then. Okay.
Absolutely. So let's take an example. You are doing a project on improving the cycle time or improving the turnaround time. Okay. So Y continuous, you're trying to improve that problem. Okay. So you have checked the one-way ANOVA, wherein you wanted to know whether if there's any significant difference between the mean of manager 1, 2, and 3. It showed a null hypothesis, which says, no, there is no significant difference between their performance. They are performing up to the mark, which says that I don't need to work on this X. Correct? It's a null hypothesis, but I would still go ahead and go for the variance test as well to conclude, okay, maybe there is no significant difference between their performances. Could be there is a significant difference in the variance also. Okay, so let's do a same example and cover one test of equal variance and one-way ANOVA and see what differences that we get. Okay, let's do that. So this is the data that I have. Okay, so we have a query on one-way ANOVA as well. So one-way ANOVA is to be done when my Y is continuous, same, and I have more than two subgroups to compare. So my X is discrete, wherein I have more than two subgroups to compare, and I want to see if there's any significant difference between the average of these three subgroups or more than two subgroups. Okay, so let's do first one-way ANOVA, and before that let's check the normality. Okay, so I go to stats, basic stats, graphical summary. Okay, so I mentioned HT as a variable which I am checking. So my p-value is lesser than 0.005. Yeah.
Yes. Right.
So what sort of a data is this?
We will accept alternative hypothesis.
We will accept alternate hypothesis. That's correct.
Right.
That is correct. And it's a normal data or a not normal data?
It's a normal data.
It's a normal data.
The p-value is less than 0.005, so yeah, so it will be normal data.
P-value is this less than, or so p-value is lesser than 0.005. So we would say it's a normal or not normal?
It is not normal.
It is not normal. It is not normal because it's a alternate hypothesis, and alternate hypothesis always says that there is a significant difference, and therefore it is not normal data. It has some special causes. If the p-value would have been greater than 0.05, then I will say that my data is normal. Okay, so remember this rule that we talked about. So here in this case, the data is not normal. Okay.
Okay. Simar, can you just repeat the last line? I just missed it.
Okay. So if the p-value is greater than 0.05, which means that there is no special cause variation, it's a null hypothesis, and null hypothesis always says that there is no impact. Therefore, we would conclude this as a normal data. There's a normal data. Okay. However, if the p-value is lesser than 0.05, we would conclude it as an alternate hypothesis, which means that yes, it's an
Right.
alternate hypothesis, which means that there is a significant difference, or there is a special cause there in the data, and therefore we would conclude that as a not normal data.
Not.
Okay, so here in this example, my data is not normal. Okay, and I will not be able to do the parametric test. I will be able to do the non-parametric test, which are not normal scenarios. Okay, so in that case, I won't not be able to do the one-way ANOVA. I will be able to do the moods median, or maybe Mann-Whitney, depending upon the subgroups that I have. Okay, so let's do the non-parametric. Okay,